Hi, in this video we are going to implement the concrete Kruskal algorithm together. So the Kruskal algorithm is going to have a single method, public void spanning tree. It's going to get a list of vertices, for example, vertex list, and it's going to get a list of edges. It's going to be the edge list. Okay, of course we have to import the java.util.list. First, we have to create the disjoint set. The name will be disjoint set is equal to a new disjoint set, and we have to define the vertex list as parameter. Okay. Then I'm going to create a list of edges for basically the minimum spanning tree is equal to a new array list. Okay. Then we have to sort the edges in ascending order according to the edge weights. So that's why we have to implement this comparable interface with the edge class, because we would like to sort it according to the weight. So that's why we have specified this compare to method like this. So we are going to use the collections.sort, and we would like to sort, of course, the edge list. Okay, and then we are going to iterate through all the edges, so the edge list. So basically we consider all the edges in ascending order, because after this sort operation the edge list will be sorted, and basically we just have to check whether adding this edge would form a cycle or not. And this is why disjoint set has been implemented, because we are able to check whether adding this new edge to the minimum spanning tree would form a cycle or not. If it's form a cycle, then we are going to discard this edge and not going to add it to the minimum spanning tree. Otherwise, we are going to include it in the minimum spanning tree. So first we are going to get the start vertex, I denoted with u, so edge.get start vertex. I'm going to have the v as the edge.get target vertex. And basically we have to check whether adding this edge, so basically disjoint set dot find, we are going to find the u.get node is not equal to the disjoint set dot find v.get node. What does it mean? That they are not in the same disjoint set. And what does it mean? That basically this edge can be added to the minimum spanning tree. Adding this edge is not going to form a cycle. What does it mean that the find would return the same ID? It means that the representative is the same for the v and for the u node. And what does it mean? That they are in the same disjoint set. And in that situation, we are not able to consider that edge. So basically, if they are not equal, it means that we are able to add the minimum spanning tree dot add the edge. We are able to include this edge in the minimum spanning tree. And basically, we just have to union the u.get node. We have to merge the two disjoint sets together, and v.get node. So basically, as I said earlier, the implementation after implementing the disjoint set, the node, and so on is very straightforward, and I think it is very resembles to the pseudocode. Okay, basically that's all about the Kruskal algorithm. Very compact. And in the end, I'm just going to print out. So for edge in the minimum spanning tree, I'm just going to print out that the edge.get start vertex plus the, for example, some spacing, okay, plus the edge.get target vertex plus some spacing again. And I think that it's going to be fine. Okay, we have to add some plus sign here. I'm going to get rid of this import and Ctrl-Shift-F to auto format. So basically it is a very compact code. We just have to sort the edge list and iterate through the sorted edges in ascending order. We have to get the vertices and we have to find out whether adding this edge to the minimum spanning tree would form a cycle or not. And if the find is going to return two distinct integers, it means that they are not going to that this edge is not going to form a cycle, so we can add it to the minimum spanning tree, and of course we have to merge the two disjoint sets for further operations. Okay, I'm going to save it, and in the application we can test it. So in the main, I'm just going to have some, sorry for that, I'm going to copy and paste a huge graph. You can download the source code because it would take a lot of time to do it. Of course, we have to import it, java.util.list. Okay, and we have to implement the edge in a different manner in the sense that the last parameter will be the edge weight. So in the edge, I'm going to have the edge weight, cut, and paste here. Okay, Ctrl-Shift-F to auto format. It's going to be the same, so doesn't matter. And let's see whether it's working fine or not. So basically the minimum spanning tree is going to have the AC, BD, CD, FG, DG, FH, and the DE edges. What does it mean? For example, AC means that the edge between A and C. For example, DE is the edge between the D and the E. Okay. And it seems correct because we have 8 vertices, we must have 7 edges. 1, 2, 3, 4, 5, 6, 7. So basically it is working fine. But let's see some straightforward example as usual. We have, okay, sorry for that, we have 3 edges. And for example, I'm going to add some edge between the A to the B, for example, just 1. Okay, from A to the C with edge weight 1, for example, and from the B to the C with edge weight, for example, 3. And I'm going to comment out all the others. Then of course, if I run the application like this, then of course, as we have expected, the AB and the AC will be in the minimum spanning tree. Why? Because this edge weight is very huge. What if, for example, I made the edge between the A and the C is very great, then of course this AC is going to be missing from the minimum spanning tree, and the AB and the BC are present. So basically it's working fine on huge graphs, it's working fine on small graphs, and what's very important I think is this disjoint set implementation. I've been looking for this disjoint set implementation for a while, and I think that it's quite good. Okay, maybe we could implement these nodes related parameters into the vertex, but as far as I am concerned, it seems a bit better solution to extract those variables into a node class, because we can separate it in the sense that this vertex is the vertex in the physical graph, but this node is basically just a virtual node in the sense that it is the component of the disjoint set, and we are going to assign the disjoint set to every vertex in the graph at the beginning. So that's why this make set is going to iterate through all the vertices, going to create a distinct node, and going to set the node for every vertex. Okay, so this is how we implement the Kruskal algorithm, and again it is a very compact code, basically like a pseudocode. Okay, we have to create a disjoint set, then we have to create the minimum spanning tree to be able to track it, then we have to sort the edges according to the edge weights, then we have to iterate through all the edges, and with the help of the disjoint set we are able to decide in order 1, so constant time complexity, whether adding this new edge would form a cycle or not. If it wouldn't form a cycle, then add it to the minimum spanning tree, otherwise just keep going. And basically we have to merge or union the two disjoint sets on every iteration. So basically that's all about the Kruskal implementation. I think that it is a very beautiful algorithm, by the way, and can be used in several fields, for example k-means clustering, data analysis and so on, so definitely worth understanding. Hope I could help a bit. Thanks for watching.